Alright, so let's take a look at 10.2 variables and expressions. So for our essential learning targets, what we're trying to do is to be able to write an expression to represent a pattern. I can identify and provide examples of variables, numerical coefficients, and constants, and I can change a word statement to an expression. So first of all, let's just take a look at reviewing numerical coefficients, variables, and constants. So here's an example at the top, 2y minus 7. So in this case, your letter is always your variable. So this one is my variable, and then my numerical coefficient is a number right in front. So in this case, my numerical coefficient is 2, and then lastly, my constant is a number that's not touching a letter. So it might look like a 7, but you also have to grab this negative sign. So if there's any negatives in front of a number, pull that in. That one is part of your constant. So if we take a look at these examples down here, the variable is always your letter. So I'm just going to grab the letter from each. This one's an N, there's an X, a K, and a C. All right, and then the constant is always the number not touching anything else. So if I take a look here, this 2 is touching the N, so that's not the constant. But this -4 hanging out by itself is the constant. Over here, there's a 10, but that's touching. Here, there's a 2. And then here, there's just a -1 by itself. So don't forget to pull this negative in as well. Numerical coefficient. So once again, this is the one that is touching. So it's any number that's touching a letter, and that actually means multiplication. So if we see this 2n, it means 2 times our n. So this is a 2, this is a 10, a -3, and then blank. So if we wanted to figure out what actually falls into here, for constant, what can you always add that doesn't change? Well, I could add a 0. So really the constant, we're adding a 0. In terms of numerical coefficient, a number that I can multiply that doesn't change anything is a 1. So for that, if you don't see a constant, it's actually just a 0. If you don't see a numerical coefficient, it's actually a 1. All right, let's take a look at an example problem. So for this one over here, we have a kitchen tile being decorated. This is an example of one of the basic designs, and then each design adds 2 of these tiles together. So you can see here, one of those tiles and another one of those tiles. And then here we have 3, and so on and so on. So first thing it says is make a table showing the number of red and white tiles in the first 5 designs. Describe the pattern. So I'm just going to fill in this table. In design 1, so this one right here, I have 2 red tiles, and then if I count the white tiles, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 white tiles. The second one over here, in design 2, I'm adding another 2 red tiles, another 10 white tiles, so that's 4 and 20. So each time I'm going to add another 2 red tiles, another 10 white tiles until I finish off my pattern. So describe the pattern. So for reds, we start with 2 and increase by 2 each time. In terms of white, we start with 10 and increase by 10 each time. All right, choose a variable and tell what it represents, then use a variable to write an expression. So for this one over here, we're going to first of all choose a variable. So I'm going to see if I can find a pattern. So what I'm trying to do is explain how many white tiles there are. So each time if I take a look at my white tiles, so I have 10, 20, 30, 40, 50, I'm going to see if it compares with something else in my table. So if I take a look, each time 2 goes to 10, 4 turns to 20, 6 turns to 30, 8 turns to 40, and 10 turns to 50. So I can actually see every single time it actually is at times 5. So if you can find your pattern, they're always going to take the number of red tiles and multiply it by 5 to get to your white tiles. So then I just need to be able to describe this as an expression. So I'm going to say, let R be red tiles. So now I know that if I ever see this letter R, I'm talking about the number of red tiles. And then an expression means I have no equal sign. I'm just going to describe how to find white tiles. So my expression would be 5R. So this means 5 times R will give me the number of white tiles. All right, last one, C. So how many white tiles will be if there are 16 red tiles? So I can actually just plug that in. Now that I have my expression 5R, I could just go 5 and then plug in my 16. 5 times 16. So if you see two numbers touching, it means you're multiplying. And then if I multiply it, I can think about this in terms of 5 times 10 plus 5 times 6. So that would give me, let's see, 50 plus 30, a total of 80. So a total of 80 tiles. So 80 white tiles. Okay. Last one, let's take a look at this. So design 1, 2, and 3. So we're going to make a table showing the number of white and blue triangles in the first 5 designs. So in the first one, I have, let's see, 3 blues and 1 white. The second one, I'm adding in a second triangle of the exact same nature. So that must mean 6 and 2. And then I can see on the top, each time it's increasing by 3. So I'm just going to follow that pattern. Whites, it looks like each one is increasing by 1. So describe the pattern for the number of blue triangles in relation to the number of white triangles. So now I need to find out between these blues and the whites, what is the connection? So I can actually see every single time if I go like this, they're always multiplying by 3. Let me just change my color. So times 3 over here, times 3, times 3, times 3, times 3. So if I was to describe the pattern in words, I would say there are 3, there are 3 blue tiles for each white tile. And then choose a variable and tell what it represents. So use a variable to write an expression for the number of blue triangles. So if I want to explain how to find blue triangles, then I don't want to define my variable as blue. So I'm going to define it as the white. So let W be white tiles. And then to describe it, how do I get from white to blue? That's 3W. So 3 times the number of white will get me to my blue tiles. How many blue tiles will there be if there's 9 white triangles? So 3 times 9, that's going to get me to 27. So there will be 27 blue triangles. All right, hopefully that helped you see how to answer some of these pattern questions in terms of using variables. So popping in numbers and letters, whereas before we were just using words to describe what's happening. If you have any questions, let me know, and I hope you have a great day. Bye.